Welcome once again to today's Maniac talk. I know I stopped giving stories for quite a while, but today Betsy didn't mind if I can give a short story. The story is based in Kenya and goes back to 1940s, 1950s, so you can imagine what life was at that time. And this is a story of a young, beautiful woman, very beautiful, and her name is Washo. If you like, you can call her Grace. And was married to a rich farmer as his third wife. The story is based, of course, I said African proverb from the Kikuyu tribe, which is my tribe. She endured all forms of discrimination exerted by her co-wives. One day, the rich farmer directed the first and the second wife to organize a large feast to celebrate a great harvest thanks to the work of Grace. Grace had done a fantastic job, and the husband decided to throw a party. On the material day, Washo, Grace, was nowhere to be seen as she was busy working her farm, about half a mile or so away. So the ceremony started without her, to the disappointment of her husband. But in the middle of the feast, a huge raven swooped a big chunk of meat that was reserved for the ceremonial offering to gods and disappeared. This brought the ceremony to a standstill, and 4 young men were sent to go after the raven. The raven kept going, but the meat became so hot, so dropped it. Unfortunately, dropped in Washo's farm where she was tilling the land. Very fascinating. So Washo, she had the sound, looked around, and she saw this very big goat meat, and she was very surprised. But she took the meat, wrapped it with banana leaves nicely, and left for home. Of course, she wanted to go show her co-wives and the husband and so forth. On the way home, she met with 4 young men who told her what had happened. She was very surprised to learn that the meat actually came from the ceremony that was taking place in her place, which she didn't know. Anyway, she took it in stride, but very thankful to God for using her to rescue her family from a big curse. You know, if you go back to those times, 1940s, you know, if you planned for events that didn't take place, then it was considered as a bad omen. So in this case, then she says, okay, the fact that God selected me to save this, I think is a big deal. So Washo is a very strong woman. She's a Syrian and who happened to be at the right place at the right time. She saw difficulties as a stepping stone for positive transformation. Our speaker today, Dr. Elizabeth Middleton, who is a senior climate scientist with Biospheric Lab here at GSFC, will narrate her story, an unconventional journey of a woman scientist who had to learn how to balance family and caregiving responsibilities. Over the last 4 decades, for example, with NASA, she has been fortunate enough to directly be involved in 4 satellite missions. She hopes to share some wisdom gathered over the years, especially with colleagues who are just starting out. Ladies and gentlemen, help me welcome Betsy Middleton.
Thank you, Charles. 4 satellites and a cornfield, but that's not all. We had FIFE and BOREAS, and before FIFE was the beginning of BRDF studies, and in between FIFE and BOREAS, I did PhD work on UVB, and then in the last 2 decades, working on fluorescence. And Dave Landis made this introductory slide for me with the cornfield, so I had to include that as well. So what were the 4 satellites? Well, actually, it's categories of Landsat, but the beginning of my job at Goddard was with the Landsat program. Then, just in the last 15 years, I've been doing the others. EO1, ESA's Fluorescence Explorer, and HyspIRI, which it was a pre-phase A mission. So I've been fortunate because many people work on concepts for satellites that never materialize. And now, just in the last, since 2015, both FLEX was selected by ESA after I've been serving on the mission advisory group for that mission for NASA. And HyspIRI has been selected as one of the designated missions to go forward, and we're calling it SBG right now, Surface Biology and Geology. So I put this slide in of my orchids because they remind me of the beauty and the complexity of our natural world. And that's what pulled me into biology and the love of nature and the things that I do. I didn't come in the usual way to be a scientist at NASA. The usual way is, first of all, you're a guy, and you've done well in college. Maybe you did a postdoc. You definitely worked in some more something like math or physics or chemistry or atmospheric sciences, one of those fields. I instead was first a science teacher. My first job out of college, that's the picture from the yellow jacket from, I think it was Mount Rainier Junior High. I taught earth science, and I taught physical science in 9th grade. But I was a pure science major as an undergraduate. I didn't have a single education course. So I didn't know I would be hired each year until August, 2 weeks before the term started. And while I was waiting also to get a job, I graduated from junior high to high school to be a high school biology teacher, I needed a job because I found myself a single parent with children 6 and 3. And so I took a job at Goddard as a contractor with Computer Sciences Corporation to tide me over while I was waiting. But of course I got hooked, right? And things go in circles, cycles, and not in a straight line the way you might expect. So I first worked in the hydrology branch, and Vince Solomonson was the branch head at that time, if anybody remembers that time. And I worked with Ross McClooney and others, but I was already 1 year into a master's program in biology in the zoology department at Maryland. And my advisor was Doug Gill. I was studying ecology, and his specialty was, at that time, was salamander populations. But I wanted to put up Gerard Vermeer, who inspired me greatly. He's an international expert on mollusks. He's totally blind from the age of 3. And he you can Google him and see all the wonderful things that he's done. But I've had hearing disability since the age of 5, and which I manage pretty well. Most people don't know that. But he showed me by example that you can overcome really difficult things. What did I do my study on? Spiders. Most of the students were doing birds and salamanders, but with 2 little ones, I wasn't going to be able to drag them out before dawn into the woods and shush them while birds were doing their thing. So this was much easier. Put Christine in a backpack and off we go to the shrubland near where I lived, and I did a survey of the size and number of the spiders and their webs and what was in their webs, the species, the number, all of that stuff, the feeding ecology of spiders, of that particular spider. So my first job as a NASA employee was with the Eastern Regional Remote Sensing Application Center. I was the first person hired from the contractor staff. Phil Cressy hired me, and I was assigned 3 states. Okay, there were 3 of these centers. One here on the East Coast, one on the West Coast, and one somewhere else, I forgot. And so the states, US states, were all apportioned to those 3 centers. And I had Maryland, Virginia, because they were close by, and also Wisconsin. So unfortunately, this didn't come out very well. This was an overhead, but showing you the kind of products we were making. So this was the Virginia State Water Control Board that was interested in this particular project, and we were using Landsat data to classify the land cover for that agency. 2 more examples. On the right, this is Charles County, Maryland, and you see it's been classified to show different land cover types. And this is where I grew up. This is Port Tobacco River, and this is Port Tobacco, and so that's where I grew up. And over here is another product from ERRSAC. This was a publication. This is the cover, and it shows James River County, which another one of those curves. I now have a home there. So my second job was to be assigned to the Earth Resources Branch. And Lucy, in the front row, was my office mate for a while. And so thank you for being here, Lucy. And I was working with Don Deering, which some of you may remember, who developed this fantastic gizmo called Parabola that measured the full hemisphere, the sky and the ground, in these angular sectors, which are shown with these little circles. And this would be placed on the end of this boom. But also this one right here is my instrument, the SE590 spectrometer. And so this is our first type of studies in West Texas off the back of a truck. By the time we got to Kansas in the mid-'80s, then we had another setup like this. We had to drag all kinds of equipment, generators and computers, and everything was big and clunky back then, if you remember. So these were the kind of data that we were obtaining. I'm showing this so it'll tie in later to the more recent work. So for me, I'm taking my data in what is called the solar principal plane. So the solar principal plane is that plane where you're looking at the sun, here's the sun, and the shadow is behind you. And the line that connects those is the solar principal plane. That's easy to see on a flat surface like a sidewalk, but if you are looking at canopy vegetation from above, it takes a shape as shown here, with a hot spot, a high value, a low spot called the cold spot, or some other name. And then we have the way these things change as the sun moves. If the sun is moving in the sky, it causes us to have different responses like this. So the first publications I had for NASA, I had some publications with the hydrology branch, but here is in Earth Resources, and having to do with what we call anisotropy of the surface. In other words, it's not all the same no matter how you look at it. It depends on the angle and the illumination. During this time, early 80s, I'm in the Earth Resources branch now. I'm going to be wanting to do research, and I only have a master's degree. And they're telling me, you're not going anywhere without a PhD. Okay, so I got my application, I took it to the branch head, and he pointed out that I was a man. And that really, I would be better off doing administrative support for the branch. And furthermore, there were 3 male branch members already enrolled in the NASA fellowship program. So I should wait my turn if I was going to be persistent. I had to wait almost 2 years for Chuck Cody, my hero. Second day on the job, I appear with the application for his signature, and from then on, I was good to go. But that was a big delay. I had to stay local for my family, and Alan Taramura, who was an expert on plant physiology, photosynthesis, and one of his topics was UVB effects on plant growth and function. This is the title of my dissertation, and you can see that I had to measure the UVB absorbing compounds in various leaves of soybean and how it affected the biomass. Also, looking at photosynthesis, and if it was measured with oxygen evolution, which was an original way of measuring photosynthetic efficiency, it was clearer to see as a function of the carotenoid content. When you have to use CO2 uptake, which is the way all of the current systems in the field, you have the additional issue of the fact that stomates are also one of the factors, and so you get more variability. So I worked on soybean, and this is the regular wild type, but also the chlorophyll B mutants, which were more yellow in color. So all of this with the plant physiology ties in to the spectral properties of the vegetation. And so that's what I'm showing here. And we're mostly looking at the visible light, or the UV light, and its effect on photosynthetic uptake. But there are other, there's chlorophyll, which most NASA people, you wouldn't know there was anything else, maybe a few carotenoids here and there. But there are many other photoreceptors in leaves. The blue light receptors, the cryptochromes, the red light receptors, the phytochromes, and they are very important in plant function. So those were the ones that I was paying more attention to at that point. So the thing about these pigments is that they have unique spectral shapes. So the wavelength from 400 to 700, chlorophyll A and B are clearly distinguished spectrally here. And you can see that all these different other pigments have specific shapes to their spectral responses. If you look at how photosynthesis, the action spectrum for photosynthesis, that is very close to the shape you get with chlorophyll A and B, and beta carotene. But the one in the middle, the phycoerythrin, that you can see it may be an important pigment for plant function, but not for photosynthesis. So during this time frame, FIFE occurred. And that was a big field experiment. And Don Deering and I and the team, Don was in charge of that. Fred found this photo in the FIFE archive. And so I recognized myself in that shirt. You remember that shirt, Christine? I believe this is Don taking pictures, which he did all the time. I know this is Tom Eck. I don't know quite who this is. I have question marks. But this is our setup on one of the fields there, the grassland. So what we would do is go out before dawn, drag everything out of the truck, set everything up, and be ready to go to take the first data set at a solar zenith angle of 60 degrees. And then every 10-degree change in solar zenith angle, we're taking a new data set until right before solar noon. And then pack everything up, throw it in the truck, drive like mad to another field, drag it all out, set it all up, try to get as close to solar noon at another site, and spend the whole afternoon the same way until finally we're down to 60 degree solar zenith angle. So we were always the last ones to drag into the FIFE meetings. So this is the grassland from FIFE. There were many studies going on, but it's a pretty homogeneous looking from the air. And this is the Kansa Prairie near Manhattan. And then there was BOREAS a decade later. And in both of these studies, the idea was to try and take very intense measurements locally, include some aircraft and other types of data that you could take remotely, and then try and understand from satellite data if you could retrieve information that could be related through this profile. And so that was both FIFE and BOREAS, the same general type of objectives. So you can see this is what we were dealing with, a different terrain altogether, all these coniferous forests and the bogs and many complexities. So 2 more shots. Actually, my friend Gloria Rapoli sent me this one that she took herself from a helicopter. And here's Gloria. This is her team, not our team. But you can see, this was the kind of thing that we were all out there doing. And this is from Don Strebel from the FIFE reunion a year and a half ago. There were no PDFs, DVDs, JPEGs, web browsers, cell phones, none of the things that we have today at our disposal. And yet, we managed to do some science. This is a picture. I don't know the exact year. You might remember this. This is the Earth Resources Branch. Here's Piers Sellers, Jim Tucker. There's Steve Unger. There's me, Elisa Levine, Fred. Yes, and Arlene, John Ranson, Daryl. Yeah, everybody is still looking at it. Ross? Wasn't that fun? Got to move on because I got more. So the FIFE BOREAS reunion, unfortunately Piers had to leave right before this. I don't think he was feeling that well. But all of these people showed up from all over the place, and it was quite a good 2 days. Back in 2005, when was it, Steve, Steve had been the first, 2007 to 2008, right in that time frame. So I became the mission scientist of the Earth Observing 1, and taking over from Steve, who had done a marvelous job of doing all the things that have to do with the technical specifications and the early testing of everything. And I'm coming in and looking more at what the possibilities were for using the data for ecosystem studies. Dave made this good image from the Advanced Land Imager of Baltimore. So you can see how very detailed you could get with those. This was before the tornado went through La Plata, and on the right is after. It was just lucky that we had those 2 scenes. And my dad had a little place like right here. So way too close. We had this archive over the almost 17 years before EO1 was turned off last year, 2017, end of March. And we took data for a number of reasons, user requests, but also our request, the Mission Science Office, CIOS sites, the calibration sites, volcanoes, that was a regular, all the blues, everywhere there are volcanoes, and where there are multiple observations over the time. We're using those for some time series work. With EO1 Hyperion, which was the first spectrometer in space, is now the prototype for the surface biology and geology follow-on to HyspIRI mission. This slide is from Rob Green, showing that for photosynthesis, we have many features in the spectrum that can be related to photosynthesis. And if we compare that with what we can get with the Landsat, you can see, we have so much more information. so we can reduce our errors and get better estimates of all kinds of functional parameters. So we're doing some time series studies. Petra did this slide, Petra Campbell, right here. And this is one of the study sites at Mangu in Africa. And so we are able to estimate carbon dynamics with certain indices pulled from those spectra as shown for this study area here, and estimate net ecosystem production. A better look at all of those, and these are in fact from the same year. Something we did just a little over a year ago, we were the first look from space that you could actually detect methane at the surface. So this is an atmospheric application or science. So you can see that this is the actual spectrum, but along with what we were able to get from HyspIRI. So this is published, and so that's a new capability that, and this is wintertime, it's low sun. This is at the end of the life of the mission when they said we wouldn't be able to get anything, and yet we're able to get a gas at the surface of the Earth.
So what was the source of it?
There was a big methane leak. So the volcano studies are very important. There's a whole community using the EO1 data for volcano monitoring. Here's another slide on that topic, and this is the lava flows that are being shown and their temperatures that are estimated from the data. There are also coastal uses. Here we have off the coast of Florida, and you can see this shows you what a Hyperion strip looks like. So they're skinny and long. But this was not supposed to be an operational system. This was new technology demonstration. Another thing we were able to do is flip over and look at the moon. And Steve has been very much involved in trying to develop this whole process for calibration, not just of the EO1 instruments, but also other satellites. We had a special issue in JSTARS in 2012. It covered a number of the different things that we were able to do. And then we were told, well, we're going to have to end the mission. We weren't ready to end the mission, and so we requested an extension. So this was the first slide of my presentation where I went to headquarters and pleaded for another year, which we were granted. And so we were able to get some really neat things that last year. All good things come to an end. This was our final meeting at the rec center, a party we had. This is the people from the EO1 team. And at that time, I mean, there were many people over the years who were involved, and especially the engineers and those folks, some of whom we did have there. And then the HyspIRI mission, that was going on in the same time frame since 2007, actually 2008, because it was defined by the 2007 decadal survey by the National Research Council. And HyspIRI was envisioned as having both the reflected part of the radiant spectrum from visible through the shortwave infrared, but also the thermal infrared. So it's covering this whole range. I coordinated, hosted, planned meetings that all took place here. We had them, I thought this one said what year. This was from 2016. I think we did 8 of these, starting in 2008. And this was to bring the community together to be planning a future with that satellite, should it become real. This was all, planning. And this was from that 2016, the people that were there. And then this was supported by aircraft. And look how big those boxes are in California, covering all of this geography with aircraft, with the instruments that simulate what would be acquired with the HyspIRI a mission should it become real. This is what it takes to cover those areas. See, making mosaics of all these strips of aircraft data. And of course, these have been selected for specific purposes with tower locations and other study sites. This actually has a 4th year and has been followed up with another campaign in Hawaii for volcanoes and coral reefs, and now recently in India. And in fact, right now, I think they're wrapping up a campaign in the country of India. This is just to show you some data from the thermal instrument, since I do mostly the hyperspectral reflectance. But this is showing the relationship of the MODIS satellite data to data collected from aircraft with the master instrument, which was a prototype for the thermal infrared. So then ESA's FLEX mission, I first was asked by ESA to join their advisory group in 2008, I believe. I'm on my 3rd term with that group. There's only like 10 people, so it's a small group. I'm the only person from the US, the only NASA representative. But this is a mission that's specifically dedicated to map solar-induced fluorescence. And you've all heard about some maps that are made globally with GOMI2 and GSFC and some others, but those are very coarse, large scale, and and not necessarily the right wavelengths, but FLEX was designed with the right planning for getting the fluorescence retrieved. But not just fluorescence, some other things too. I guess I forgot to mention, this is Wout Verhoef, who was on the MAG, the Mission Advisory Group. And back when I was trying to come up with a project for my PhD, I wanted to use his new model that he developed as his dissertation in the 1980s, which was called SAIL, S-A-I-L. And it was a radiative transfer. But for some reason, every time I tried to make this project, it was not accepted by the branch management. That's why I ended up doing the UV. But here I am, having him as a colleague all those years later on the MAG. And not only that, this is his protege, Christian van der Tol, the author of the SCOPE model that you may hear about if you're doing anything with fluorescence these days. I was the keynote speaker at this. I was invited to give the talk there were actually 3 keynote speakers, but I was the one on fluorescence, because he was so well versed, he had 2 other topics that he was an expert on. And that was September 2016. As part of being a part of the FLEX mission, we planned an airborne campaign, and this is a slide from a paper that was published last year. Primarily, I want to show you that this shows hysteresis. The hysteresis is a cycling function. So in the morning, this reflectance index compared with a red fluorescence starts low values here of fluorescence. Solar noon has the highest values, but then through the day decays back to here. The PRI is changing also, but we have a difference between the mature stands of forest, this is a loblolly forest, and the young stands. And we also see that if we take the ratio of the red to far red fluorescence, we can estimate light use efficiency, but we have to avoid the middle of the day. Through the rest of the day, we can get a linear response. So since then, there have been some other meetings with some of these same people, and you may recognize Anatoly Gittleson, formerly the University of Nebraska, and all the activities that are out there in Mead, Nebraska. He's a real well-known expert on pigments and reflectance indices for that. And so some of the same people have attended these meetings. And last year, I organized an IGARS talk that was in Fort Worth, and we had a session on spectroscopy from space. But there was also a session on fluorescence. And this is Jose Moreno, the PI of FLEX, and his PhD student, Neus Sabater. And I'm on her dissertation committee. So I'll be going there next month. Somewhere around 1998 to 2000, Emmett Chappell, who was the one who developed the fluorescence program here at USDA and Goddard. Some of you may remember Emmett. He retired, and I took over in charge of that group. And we were over at BARC for a number of years, but we had to come back over here. So I want to show you just a couple things here about the fluorescence spectra. You see it has a particular shape with peaks in the red and far red, and some species differences, and some information we can gain from the underlying photochemistry. We do a lot of our measurements at the nearby Beltsville Cornfield, and we have our own tower with instrumentation here. And we're looking at a number of years at different nitrogen treatments. And here's that fluorescence ratio again. And so so you see things aren't linear. It's the high value here is low efficiency. So you have low efficiency both with too much nitrogen and with too little. There is our tower, but on the same site is the flux tower, eddy covariance flux tower. And our tower measures the BRDF, remember that from the beginning of the talk, but in a simpler way than what the parabola was acquiring. Each dot shows you the location of a collection. And then we can get things like, here is for fluorescence, the shape in the solar principal plane of the far red fluorescence and the red fluorescence, the hot spot, the nadir, etc. And those things change over the day, just like I showed you the solar zenith angle affects the BRDF. And it affects the two bands differently. But the ratio is much more stable. We also did BRDF with the photochemical reflectance index, quite a bit of this. What I want to show here is over a full season, all of the blue ones on the top here, those were the water, given additional water. But the ones on the bottom were the droughted ones. And notice how they have the low values. When we have a big rain event, shown here, everything collapses to look the same. So when we have stress, we can separate these things out. And then we get down here to the senescence at the end of the time period. So I'll go quickly through some of these pictures of us out there in various measurement regimes. Last year, collecting some new data, we have one of the very few what's called a Flox box and some new data. And all of this depends on knowing the photobiology of these pigments. And with the spectrometer from space, we have these dropouts because of the atmosphere. So we have to model them through models that'll give us the full spectra. And of course, what I've been doing is trying to tie leaf level. Some on our group, Petra has a drone effort. We have the aircraft I mentioned with the FLEX campaign and satellite data. So we're covering the whole range here. This is an example from that Parker track of separating out all of these age classes just with the spectra. We did just as good a job as with the LIDAR for biomass. Some recent publications, this is using EO1 Hyperion data and the predicted production from MODIS data, combining morning and afternoon data. We also, Fred has got a study on using the space station. And here's one I'm working on right now with the GOMI fluorescence data with MODIS, showing some similarities and some retrievals. So we'll see that later. This was the GOMI map, annual average of the fluorescence. And right now, I'm the guest editor for an issue in remote sensing on quantifying, validating remote sensing measurements of chlorophyll fluorescence. And of course, all of this, a lot of these things have taken me to interesting places. This is where the MAG meets in Noordwijk, Netherlands, and they were having an event. So Noordwijk for Wout's retirement. This was in Gende. This is in Rome for the fluorescence workshop, and Joanna Joyner was there, and Gina Mohammed, the other woman on this second and third mags. We did a tour at night because that's when we could fit it in. We have some fun here as well. Try to get together. We haven't done that in a while. It must be time. With all those meetings I've gone to, this is where I've been for NASA travel over my career. I might have left a couple out, but that's mostly it. And then add in the blue places I've gone on my own. So I haven't gotten to lots of places, so I better get with it if I want to do that, right? Over my career, this is the total so far, 86 peer-reviewed journal or book manuscripts, and they cover all these topics of the BRDF. In parentheses are the ones I senior authored: UVB, fluorescence, instruments and satellites, carbon, APAR, reflectance indices, and at least 84 proceedings and short papers. And I did have the Nordberg Award in 2012. That was for Earth Science. And also the Exceptional Service Medal, a Career Achievement Award in the Hydrology and Biospheric Sciences. And everything is spirals. Let me give you a few things on my personal life. My mother and dad, Betty and George McPhee, their engagement picture. This is me, my sister, that's me and my sister Gail, that's me. I don't remember the cat. This is the house that I mostly grew up in, which was a colonial home. This is, I think that's my mother, but here's Mom, Dad, and my youngest brother Mike. Here are the four of us: me, Gail, George, and Mike. And this was my confirmation. Another look at Chandler's Hope from another angle. And I'm standing at the far end where they are standing. This is my mother and dad and Elva, my grandmother. And we were on the annual colonial home tours. So they're all dressed up for the tour that year. So I went to La Plata School. Everything was right there. This is a rural county, elementary, middle school, high school, and the auditorium and gym. I was in the 4-H, Head, Heart, Hands, and Health. And I don't actually know what this is. This was our principal. But we were being called out for something. And I have that photo. From the yearbook, my senior yearbook, there's the science club. I was a cheerleader. We didn't have many options as girls back then. There were no athletic teams for girls, so you could be a cheerleader if you made the cut. And Future Teachers of America. And this is Jenny Hoyle. She was an exchange student. I'm going to be visiting her in England this fall. This is my favorite teacher, Claudine O'Brien. She taught me Latin for 2 years and literature. And my senior term paper was on the rainbow. And that was my first introduction to spectral information. I saw her at the 25th reunion. I went up to Miss O'Brien, who was there, and I said, "Miss O'Brien, I wanted you to know I became a scientist." She said, "Oh dear." I thought you would be a writer. Little does she know, right? So I was in the court of Queen Nicotina. I tried to find a picture, ran out of time. That was at the fall county fair, and they picked the queen by spinning the wheel. And I won a statewide full tuition scholarship to the University of Maryland, so that's why I went there.
Were you Queen Nicotina because it was tobacco country?
Oh, yeah.
Thank you.
Yes, oh, yes. The farm I grew up on was a tobacco farm in Port Tobacco. I had a kind of normal, had a boyfriend. He was just a friend. That's Buddy. My graduation picture, some of our class, only 120 in our class. This is University of Maryland, my college picture. I was in the senior women's mortarboard, the honorary, also the junior women's honorary. I was president of a dorm of 500 girls in my junior year, and on the campus executive council. My one activity outside of academics was the women's choir, which is here. So this was the women's choir. Also, there was a men's choir, and we performed together. Then I have my family, Ted and Christine is here. There I am with my dad, my mother in the middle, my stepmother, beloved Jackie. Dad was at the American Legion, what do you call the guy, the head guy, numerous times. I'm trying to finish up here. My brother and his Russian wife, Olga, and my nephew, who's my grandkid stand-in. He just turned 13. I'm taking him to a Wizards game on Saturday for his birthday, which was last week. Here's Christine with her beloved dog, Henry. At Christmas time. My son reluctantly getting his picture taken with Melissa. And we took Henry on an adventure with Ted. My garden. And these are my tomato plots. I've got 4 of those. I'm in the hiking club, and so this was a shot, we did a tour after a hike, and that was in an old house, and it was a funny picture at the time. 2 hikes, but these are the other things I do. I lap swim, I try to play some tennis. They're awfully good tennis players, and aerobics as often as I can, and contra dancing, which is a new thing for being in James City County. Lots of fun. So choral music for 30 years. I sang with Columbia Pro Cantari, and that's approximately where I am. I think when Dave changed the size of this, that's where I am. The circle shifted. And this last Christmas, singing in Christmas Eve service, and some other things I do, knit. Haven't done anything intricate like that in a while, or reading what I think is good literature. My living room at Christmas. And I do want to say, not everything is easy, as we all know. Some of you may remember when this happened, which was in 2004. And this is an X-ray. I put this in just to say, things happen that you don't expect, and you still have to deal with them. I was non-weight bearing for a year. I wasn't able to come into Goddard unless someone brought me here. And eventually I got most of this out, but this was a very complicated break, and it wouldn't heal. But we all have disappointments, we all have setbacks, and what we have to do is just keep on going, because we can get past this. Now, I could have retired at this point. I mean, it would have been like borderline, but I had things to do, by golly. So, peanuts. I'm not against having a girl in our hiking group. It'll probably be good for her. Sooner or later, of course, she'll learn just how difficult these hikes can be. Harriet, wait for the rest of us. And from my hiker friend, Rick Allen of Richmond, Not all who wander are lost, which I think was a good thing to keep in mind. So that was the baby picture that was requested and a recent selfie from last year. And oh, I want to give a call out to these wonderful young women from the Marjorie Stoneman Douglas High School. I've listed the ones that I've seen who've gone out there and said powerful things. I'm also a fan of the mayor of San Juan, who's, been very, very strong. And if only some of these girls will conquer the issue they're dealing now with gun control and become scientists, we need more of these girls to go into the sciences. So that's all I have today. Thank you all.